So let's read this question. What is a subspace of a vector space? In linear algebra, subspaces are simply smaller fractions within a larger space. Yeah, it's pretty self-explanatory. And a non-empty subset of vector space is a subspace when it is a vector space with the same operations defined in the original vector space. So this is a more technical definition of it. Go ahead and pause the video, read it for yourself. And our first example is, can we find a subspace in R3? Or can we find a subspace in a three-dimensional plane? Let's figure that out. So how can we show that this set, and assuming that x1 and x3 are real numbers, is a subspace of R3 with the standard operations? So let's define these coordinates as w. And we know already that set w is non-empty because it contains the zero vector, which is the y component. And graphically, the set w can be interpreted as the xz plane, as shown by this graph. Now, is it closed under addition? And if so, why? And it turns out that it is, as the sum of any two vectors in the xz plane must also lie in the xz plane. In other words, if we have x1, 0, x3, and y1, 0, y3, and we were to add the two of them, we end up getting the following coordinates over here. And it turns out it's also in the set of w. Now, is it closed under scalar multiplication? Well, let's grab x1, 0, x3, let it be in the set w, and let's see what happens when we multiply it by scalar c. Well, if you multiply the set by c, you end up with the following. Let's see here. C times x1, 0, x3. You end up getting these values right here. And you'll notice that there's a 0 in its second component, so therefore it must be in the set. Now, we've only verified the fact that it's closed under scalar multiplication as well as addition. The other 8 axioms will be left for you to decide or deduce. Yeah, so establishing the fact that a set is a vector space, you do have to verify all 10 vector space axioms. And if the set happens to be a non-empty subset of a larger vector space, then most of the 10 properties end up being inherited from the large space and don't need further elaboration. And there you have it. So fundamentally, if W is a non-empty subset of vector space, then it is a subspace of the vector space if and only if two conditions are present. And that is, if U and V are in the set, then that means the sum of those two components are in the set. And if U is in the set and C is in a scalar, then the scalar multiple of U is also in the set.